Kuzuzambola, Bhutan e-learning project welcomes you to this physics lesson for Key Stage 5, classes 11 and 12. My name is Dechinongchu. Where is this sound coming from? I guess this is the sound from fluid. By the way, do you all love to listen to the music? And for me, I'm totally passionate about listening to the music. So, as we listen to the music, we hear the sounds from different musical instruments like piano, guitar, flute, yangchen, damnyan, and so many other instruments. But as we listen to the music, do we hear these sounds from different instruments separately, or do we hear all the sounds together? And of course, we hear the sounds together. Because sound coming from these different instruments, they get superimposed, they overlap on each other, and as they reach to our ear, we hear all these sounds perfectly synced together and in harmony. So in today's lesson, I want to talk to you about some important properties of waves like superposition of wave, diffraction, and finally polarization of waves. And to understand the properties of waves, first we need to know some basic concepts related to waves. So first let us look at some basic concepts related to waves. First one is displacement. So displacement here indicates the distance traveled by the particles in a wave. And amplitude is the maximum displacement covered by the particle. Wavelength is the distance between two consecutive crests or toe in case of transverse wave, and if it is longitudinal wave, then the distance between the consecutive compression or rarefaction is called wavelength. And the next one is frequency. Frequency is the total number of waves that can pass through the point in 1 second. And the inverse relation of frequency is time period. So time period means it is the time taken by one complete wave to pass through the point. And wave propagation. Of course, I talked about wave propagation in my previous lesson based on Huygens principle. So I hope you know how wave actually propagates. And the next concept is path difference. So path difference actually is the distance between two particles in a wave. We represent with letter x to show the path difference. If you look at this definition, it says the distance between two positions along the path of a light wave, or it can be even a sound wave. And we have phase difference. Phase difference will show difference in angle between the two consecutive crests or toe in a wave. So in case of phase difference, we will look at the relative position of crest and toe, in which phase difference will indicate the difference in angle between crest and toe, or it can be between crest and toe and toe. So let me ask you this question. Have you ever observed a kind of scenario in which you happen to place your mobile phone near to your TV screen? When your phone rings, you might have observed that the screen of TV shakes, and at the same time the sound gets diminished. And have you ever questioned why is this happening? This is because when two or more waves propagate either in same direction or in opposite direction, sometimes they overlap on each other. As they overlap, their amplitude and displacements gets modified. So on the process, they interfere among themselves, and that is the reason why the mobile that is kept near the TV screen sometimes produces some different sound when mobile rings nearby the TV screen. Another example is, listen to the radio. You might have observed this scenario as you try to find the channel, for example, Kuzu FM. Sometimes some other channel gets in the middle and you don't find the Kuzu channel directly. The reason is all these waves are coming together in the air and somehow they overlap. So on the process, when you look for one channel, sometimes you get the sound from different channel. That is the reason why sound waves or either light waves overlap as they travel together or either in opposite directions. So that is called superposition of waves. So let us look at the principle of superposition of waves. It says when a number of waves get superimposed, the resultant displacement is equal to the vector sum of displacement of all waves. It is like if I give you 10 Newton and 20 Newton, the total amount that you will receive is 30 Newton. Similarly, if there are two or more waves traveling together, the resultant wave will have the sum. The amplitude of resultant wave will be the sum of the individual waves. And mathematically we can represent y is equal to y1 plus y2 plus y3, and if we have n number of waves, then we can write yn. So y1, y2, y3 till yn indicates the displacement of individual waves, whereas this y is the displacement of resultant wave. So this process, the process of overlapping the waves together, is called interference. And as waves interfere, their energy gets modified. So the redistribution of light energy due to superposition of light waves from two coherent sources of light is called interference of light. And to make you clear about the interference, let us look at this example. So carefully observe the diagram. In this diagram you can see that two waves are traveling in opposite direction. If you look at this blue wave, it is traveling towards the left, and if you look at this red wave, it is traveling towards the right. Now we have to read this graph from bottom to top. As we go up, time increases, and let's see what happens to the superposition of waves. So you can observe here, at this end, two waves are traveling in opposite direction. You can see as we go up, as time increases, these two waves are coming together in opposite direction. And at this point, you can see these two waves, the red wave and blue wave, overlapped, and the resulting wave is this black one. So here what you need to understand is, since these two waves are overlapping in phase, I hope you know what is in phase and out phase. We already talked in our previous lesson. Since these two waves are overlapping in phase to each other, the resulting wave is having bigger amplitude comparing to two original waves. So this kind of interference in wave is called constructive interference, meaning these two waves has constructed positively, and you can see the result is larger than original wave amplitude. So we call it constructive interference. Now, where have you observed constructive interference in your daily life? Just to give you an example, why do you think we are using more than two bulbs or light in single room? That is because if we put on more light in a room, so as they travel, all these light rays will overlap together and it will produce more brightness. That is the meaning of constructive interference. And to have constructive interference, you need to know these two important conditions. For constructive interference to take place, the phase difference between two waves, for example, this wave and this wave, the phase difference should be 2n pi, and the path difference should be n lambda. And if you look at these two formula, we can clearly see that phase difference talks about the angle between two waves. Pi here means angle. And if you look at the path difference, it is talking about the wavelength, that is lambda. So path difference, as I said, it describes the position in a wave in terms of length, whereas phase difference talks about the difference in terms of angle between two waves. Now again, let us look at this example. Now you can see same thing here. Two waves are traveling opposite to each other, and you can see in this case one of the wave is crest and another one is trough. So they are traveling in opposite direction, and as these two waves reach here, you can see one wave is crest, another wave is trough. Since they are overlapping out of phase to each other, the resultant wave is having less or small amplitude comparing to the individual waves amplitude. So this kind of interference of light is called destructive interference, which means they try to destroy each other. However, since the magnitude of the amplitude is different, it has not totally destroyed. It is not zero here. We have some amplitude. However, this amplitude is this difference in the amplitude of this wave and this wave. So we call it destructive interference. Now again in our daily life, where do we observe this kind of interference? Just to give you one example, this happens especially in a theater, where the theater wall is built up in such a way that as light sound waves travel to the wall and as it reflects, the reflected sound wave and the original sound wave will somehow overlap, and they will try to minimize the amount of amplitude, the resultant amplitude. And there we hear the soothing sound, not very loud sound. And in this example, you need to know the two waves, sound waves coming from opposite direction. They try to superimpose together destructively. So the resultant amplitude becomes smaller than the individual amplitude. So for destructive interference to take place, the phase difference between two waves should be 2n minus 1 times pi. Again, this pi indicates the difference in angle between two waves. And the path difference should be 2n minus 1 over 2 times lambda. So lambda here indicates the wavelength, and the path difference, as I said, is the difference in the position of the wavelength of a wave. So if you look at this video clip, we can clearly observe the constructive interference and destructive interference. Look at green wave and the blue wave. As crest of blue wave superimposed with the crest of green wave, the resulting wave, which is red in color, the amplitude becomes large. However, if crest of blue wave and the trough of green wave superimpose on each other, the resultant amplitude of this red wave becomes minimal. So that indicates destructive interference. So from this clip, we can observe both constructive and destructive interference. Now let us look at the interference of light waves with the help of this simple video. As you look at the video, you can see the light is coming from sun and it enters through a single slit, and as it reaches here, you can see now light will start coming out from double slit. Two slits separated with certain distance. Light waves which comes from slit S1 and S2 will get superimposed, and let us see what happens when it falls on the screen. As it falls on the screen, you can see we have distinct different layers of color. As light waves superimpose in each other, they form something called interference pattern. And interference pattern depends on path difference and the phase difference. As you look here, this bright yellow spots indicates constructive interference, which means the light waves falling on this part of the screen has superimposed constructively. So we call this one as bright fringes or bright spot. And the darker ones indicates that light waves, as they fall on the screen, has superimposed destructively. Hence, there is no color at these points, showing that light waves have superimposed destructively. So we call this as interference pattern. Now let us look at another property of wave. We call it diffraction of light. So diffraction means the bending property of waves. It is very clear for us that sound wave can bend. However, it is very difficult for us to observe the bending of a light. As I said in my previous lesson, light can actually bend. However, this is not visible to our eye since the wavelength of light is very small comparing to wavelength of sound. However, let us look at how actually light diffract. So diffraction of light can be simply defined as bending or spreading of light rays when it falls on an aperture or an obstacle. For instance, as you put on the torch on the walls, from the corner of the walls or from the edge of the walls, you might see light somehow spreads. That is called diffractional light. But diffraction here, in case of light, may not bend something like rope or something like water. However, diffraction is just changing the direction of light rays. But most of the people confuse the difference between diffraction and refraction, because refraction also says changing direction of light. Diffraction also means bending of light, which means, of course, light cannot bend up and down. It somehow changes direction. But the difference is, in refraction, light passes from one medium to another medium. Diffraction can take place within same medium. So, just like interference, as light diffracts, it will form the pattern. And if you look at this pattern, this is called diffraction pattern. But there is a difference between interference pattern and diffraction pattern. You have observed interference pattern. If you remember, in case of interference pattern, we have equal bandwidth between bright fringes and dark fringes. However, in this case, you can see the central bright fringe is bigger comparing to the bright fringes which goes outward. As it goes outward, the brightness of these bright fringes decreases. However, in interference pattern, the brightness remains same across all the fringes. So let us do a simple experiment to show the diffraction of light. And in our daily life, we may not observe diffraction as much as reflection, because the phenomenon of diffraction is very rare. So let us look at few examples of diffraction. And the first one is bending of light through the door. As you look at this picture, you can see light is coming into the room from outside. However, if you observe this area of the room, you can see it is dimly lit by the light, which means, of course, light is not traveling straight from this part of the gap to the other end of the wall. However, it is getting spreaded to certain area. This is called diffraction of light. Another example is setting of the sun. Especially towards evening or in the early morning, we can observe this kind of reddish light. This indicates that as light travels, it diffracts from tree or from mountain. So we see the color of sunlight like this, indicating the process of diffraction. Another very good example of diffraction is in a hologram. You can see here, we have image of flower, and this image of flower is holographic image. Light is being passed from this end, and as it passes through this crystal, which has the diffraction gratings on it, produces the image of a flower. So in this process also, the image is actually formed due to diffraction of light. And we also have some applications of diffraction in science. For example, in X-ray, the process of doing X-ray involves diffraction of X-rays. And also to study the atomic structure of crystals, we need to use the light wave which has high frequency, and these waves actually diffract through the crystals, giving us the clear structure of the atomic crystals. And the next property that we will look at is the polarization of light. So what you need to understand is, actually when light wave propagates, the electric field and magnetic field of light waves vibrate perpendicular to each other in a medium. So if you observe here, this light wave which is vibrating up and down is electric field, and the rate wave which is vibrating to and fro is the magnetic field. And you can clearly see that these two fields are vibrating perpendicular to each other. So from here we can clearly understand that light, as it travels in the air, it travels in all the direction. At the same time, these two fields vibrate perpendicular to each other. This kind of light wave is called unpolarized light wave. So the process of making the light wave to travel in single direction or in one direction is called polarization of light. Now you'll understand this more as I show you this. In this picture, you can observe that this part indicates the non-polarized wave, or we call it unpolarized wave. And here you can see the wave of light is traveling in all the direction. However, once we place a device called Polaroid, then the wave starts to travel only in one direction. This is called polarized wave, and the process of making light wave to pass only in one direction is called polarization of light. Now let me show you the concept of polarization practically using these polarized glasses and the laser light. So first, you check the intensity of this laser light. As I point there, you can see the brightness or the intensity of this light. Now let's say I want to keep these two polarized glasses parallel to each other. When I place these two glasses parallel to each other, the slits are parallel to each other, so both of them will block only one component of the wave. Either it will block electric field or it will block magnetic field. And now you can check the difference in the brightness of light. So you can observe this carefully. As light comes up from these two glasses, which is placed parallel to each other, it is not as bright as the original source, showing that one part of the component has been blocked, either electric field or magnetic field. Now, if I change the position of these two glasses, if I place them perpendicular to each other, now you can see the position has been changed. The slits position are also perpendicular to each other. Now let's check what happens to the brightness of light coming out from these two polarized glasses. Once more, please observe carefully and see what is happening to the intensity of light or the brightness of light coming from these two polaroids. Hope you have seen the differences. As I keep these two glasses like this, if the first glass blocks the electric field which is vibrating up and down, then this glass will block the magnetic field which is vibrating to and fro. Hence, it will try to block the light completely coming out of it. That is why the intensity of light decreases considerably. So some of the applications of the concept of polarizations are in the following. The first, I already explained, we use in sunglasses, and of course in car windshield. There is a reason why car windshield is placed in certain angle. It is not only to block the current of the wind, it will also block the certain amount of light coming towards the driver or the passenger. So in this case also we use the concept of polarization, and of course in 3D movies. In today's lesson, we looked into the concept of superposition of waves, that is interference, and we looked at the diffraction of light, and we looked at the polarization of light. And now to end the lesson, you can do these questions as an extended work to check your understanding. So the first question is, light waves can be polarized while sound waves cannot be. So why? And the second one is, what evidence is there to show that sound wave is not electromagnetic in nature? I hope you do these questions, and thank you so much for investing your time with me, and of course, getting share.